Hello there, you're welcome to my YouTube channel. So in today's video, we are going to be solving this equation to find the value of t. So we have t raised to power t is equal to what? 33. So let us try some integers raised to the power of the same integers because we have t raised to power t. So 1 raised to power 1 is what? 1. And 1 is not up to 33. So let us check 2 raised to power 2. 2 raised to power 2 is what? 4. And 4 is not up to 33. How about 3 raised to power 3? This is what? 27. 27 is not up to what? 33. So let us check 4 raised to power 4. 4 raised to power 4 is what? 256. Now, 256 is bigger than 33. So what does this tell us? This tells us that what? The value of t lies between 3 and 4. Because 3 raised to power 3 is 27. And 27 is less than 33. While 4 raised to power 4 is 256. And 256 is bigger than 33. So this has given us a clear picture of what the value of t will be. So the value of t is between 3 and 4. So since we have t raised to power t, let us take the natural logarithm of both sides. So that will be what? Ln t raised to power t is equal to what? Ln 33. Now, this is the logarithm of both sides. Now, from one of the laws of logarithm, if you have log a raised to power b, this can be written as what? Log b. This can be written as b log a. Now, as you can see here, the power of the logarithm, which is b, was used to multiply the logarithm, and it becomes what? The coefficient of the logarithm. This b here was brought down to this place, and it became the coefficient of the logarithm. So we are going to be doing the same thing here. This t here, we are going to bring it down here so that it becomes what? The coefficient of the logarithm. So this t will be dropped to this place. We apply this law of logarithm to it. So this one will come to this place. So that will be what? T ln t is equal to what? Ln 33. Now we can't just find the value of t because we have t ln t. So what we are going to use to find the value of t is the Lambert W function. The Lambert W function. So to find the value of t, we use the Lambert W function. And the Lambert W function states that the coefficient of this function e, that if the coefficient of this function is still raised to the value of the same coefficient, what you are going to get is the coefficient. Like we have x here. X is the coefficient of this e, and this x is still raised to power is still raised to the power of the same x. So what you are going to get as your result will be what? X. Let me give you another illustration. If you have now look at this, you can see that we have 2 as the coefficient of this e, and this 2 is still raised to the power of 2. What you are going to get is what? It's still the same 2. Like we have here, we have x as the coefficient of e, and this x is still raised to the power of x. So what we are going to get will be what? X. But we have a problem here. What we have here is e, and what we have here is ln. Ln and e are inverse functions. So how are we going to introduce e into this equation so that we can introduce the Lambert W function inside the equation? Let me show you something. Do you know that if you have e raised to power ln x, that this is equal to x? Do you know that I can rewrite this to be what? E raised to power what? Log x to the base of e. Why? Since it has a common base of e and the general base of e, this simply means that this log e here and this e, that both of them are inverse functions. it means that they can cancel out. So this can cancel out this, and you now be left with what? X. So I'm going to be doing the same thing to this t. I will rewrite this t. I will rewrite this t to be what? This t here, I will rewrite t to be what? E raised to power what? Ln t. T is equal to e raised to power what? Ln t. Why? Because I told you that e and ln are inverse functions, meaning that they can cancel out. This ln can cancel out this t. And when they cancel out, you see that we are still left with t. We have t here and we are still left with the same t. So I'll rewrite this t to be what? E raised to power what? Ln t. This t here. Let me rewrite the value in this equation. So this t will now change to what? E raised to power what? Ln t. Because I want to introduce e into the equation so that I can apply the Lambert W function. So I'll rewrite this t to be this. Then we have what? Ln t here. Ln t is equal to what? Ln 33. Ln 33. Good. Now let me arrange this in such a way that I can be able to apply the Lambert W function. Which means this one will come before this one. Then this one I'll put it in the middle, so that I can be able to apply the Lambert W function correctly. Like this, I can't apply it, so I have to arrange it well in a way that I can be able to apply the Lambert W function. So this comes first. So that would be what? Ln t. E. This comes second. Raised to power what? Ln t is equal to what? Ln 33. Ln 33. Now, do you notice something? Look at what from this explanation. Look at what happened. We have ln t as the coefficient of this e, and we also have ln t as what? As the power of this e. So that means that we are going to what? Apply the Lambert W function. From the Lambert W function, you have x as what? As the coefficient of this e, and you have x as the power of this e. So what you're going to get is what? X. That means that if we apply the Lambert W function, since we have ln t as the coefficient of this e, and we have ln t as the power of this e, if we apply the Lambert W function, what we are going to get is what? Ln t. Because ln t is what? The coefficient of e, and ln t is still the power of e. So let us apply the Lambert W function. Lambert W function of what? Ln t. Ln t. E raised to power what? Ln t is equal to what? Lambert W function of what? Ln 33. Now, if you apply the Lambert W function, what we are going to get here is what? Ln t. So we have what? Ln t is equal to what? Lambert W function of what? Ln 33. Now remember that I told you that ln and e are inverse functions, that they can cancel out. So I want to get rid of this natural logarithm so that I'll have only t. So what I'm going to do is to introduce e to the both sides. So let me introduce e to both sides. So that will be what? E raised to power what? Ln t is equal to what? E raised to power what? Lambert W function of what? Ln 33. So that means that since e and ln are inverse function, they can do what? They can cancel out. So ln can cancel e. So I'll be left with what? T is equal to what? E raised to power Lambert W function of what? Ln 33. Now this is the value of t that can satisfy this equation. Try this out in your calculator and you see what you get as your result. Please don't forget to support me by subscribing to my channel.